Welcome to one and all present here for this meeting. My name is Gaurav, and on behalf of the the Journal Club, I welcome you all. Today we have Gilad Feldman. He's an assistant professor with the psychology department at the University of Hong Kong. And to put it aptly, his research areas revolve around decision-making, social psychology, or even judgment, choice, agency, morality, folk psychology, etc. He has, sorry, he's taken his time to talk to us about his topic of the value and importance of replications, which calls for the multiple replications of prior research in order to enhance the field of psychology using rigorous scientific approaches. So on behalf of the South Asian Journal Club and Christ University, I would like to extend a warm welcome to Professor Gilad Feldman and all those who have attended this event.
Great. Thank you very much for the introduction. Very happy for the opportunity to talk to you. I've been wanting to engage more with the region in Asia. We're very close yet very far somehow. So it's nice that we get the chance to kind of discuss things. And it's always a pleasure to talk about the topics of, that I care about, open science, replication. And it's great that you care about this. We have a big team of early career researchers. I'll tell you a little bit about that, but it would be also very nice if some of you would think that you would want to join us on that. So we're very open to having any of you, if you're interested in this, kind of like reach out and tell us that you want to do this with us. So the topic today, value and importance of replications, a lot of slides, many of them hidden, so I won't be going over all of that, but in the spirit of open science, all the slides are downloadable. So you have the QR code or you have this link over here. So you'll be able to go press on any of the links that you think are interesting and check things out for yourself. In addition, I try and make all of my talks available on YouTube or on the OSF. So hopefully this one as well, recording this so that we can share this with whoever is not here, or if you want to go back and have a look at this to see some of the things that you might miss because it's too fast. So when I talk to people about replications, I start with this general question about, let's say that we live in an ideal world, everything is great, science is working as expected. What kind of ratio would you expect of the published literature to be novel, and what ratio should be replications out of that? And another question is, for example, I am in social psychology, so we have this journal called the Journal of Experimental Social Psychology, Psychological Science, doing empirical research, a lot of experiments in social psychology. So what do you think is the percentage of replications in these journals? So once you think about this, have like a percentage in mind. I'll tell you what I've received in workshops and courses that I gave so far. So people estimate that right now the replication rate, so for example, in Journal of Experimental Social Psychology, is that they publish something like 10%, and that 30% of their submissions to Journal of Experimental Social Psychology are replications. But it seems like, at least from this kind of perception of what Journal of Experimental Social Psychology does, it seems to be a little bit lower than what people think should be happening in an ideal world. So in an ideal world where science is working as expected, people think that in top tier journals, it should be something like a third, 32%. And in an average empirical journal, it should be 38%. So slightly higher than that, but about the same. So what is happening in our field? So if we look at meta-scientific evidence, we very fast arrive at the conclusion that we have a major issue because we simply don't do replications. There is a very strong bias against doing replications, and there's even a stronger bias against publishing replications. And given the last 6 years, I've been trying to do a lot of replications and getting them published in journals. I've been experiencing this firsthand when I submit replications to journals. So this is the meta-scientific evidence that we have. Right now, just came out in 2023. What is the rate for replications in social psychology, the ratio of published literature? It's 0.2%. It's not 2%, it's 0.2%. So it means that out of 85 about 1,000 articles, there's 169 of those that are labeled as replications. Perhaps this is a problem in psychology. So what happens if we go to economics or linguistics or ecology or some of the other things? It's a very similar rates. Actually, the highest one came from like psychology in 2021 in a very specific subset, but it seems like generally the ratio is very, very bad, going all the way to very close to zero in some subsets of biology. So we have a problem. We're just not doing this enough. I'll start from the very first kind of like paper that brought this to social psychology awareness. So this is from 2012, a seminal paper that kind of looked at this trend of how many of publications we have and how many of those are replications. And we can see a very small rate. But what's more important, I think, are these quotes. So we really need as a field to try and decide what is good enough for replication rates. Obviously, 0.2% cannot be a good enough rate for psychology. So they tried in 2012 to come up with a rule of thumb, and they were saying that it seems very, very strange if there's a publication that is cited more than 100 times. If there's no attempt of replicating this seems like something is very off. So at the very least, for the highly impactful papers with more than 100 citations, we need some revisiting in order to make sure that everything is okay. So this is kind of like a meta science level 2012. Let's have a look at actually what's happening in Journal of Experimental Social Psychology. The reason why we know what's happening over there is because the former editor, Roger, here shared this with us. So I am very active on Twitter, now called X. Back in 2020, he shared that roughly 670 manuscripts submitted to JESP, Journal of Experimental Social Psychology. Only 12 had something related to replications in the title, so that is 1.7%. What's funny about this is that 2019 is the year where we started to submit replications, and we submitted a lot to Journal of Experimental Social Psychology. So half of these are from our team. So just imagine, so we've got like 6 out of 670 that are not coming from our team, submissions to Journal of Experimental Social Psychology. And it's even worse than this because our replication success rate in publication is lower than 30% over there. So it just means that we're just not doing very well in publishing with that journal replications. And another very big journal in social psychology called JPSP has something very similar at 2.6. So compare this to the ratio that people expect from Journal of Experimental Social Psychology. It's nothing close to 10%, definitely submissions of 30%. That is just very far from reality. How about 2020? Maybe Journal of Experimental Social Psychology, we have an open science editor. Maybe things improved, but actually 2020 was even worse. So it was 1.5. So my conclusion from all of this is just people are not submitting any replications, and definitely not a lot of publications with replications. So we can already see that there's a big problem comparing reality to expectations. But generally, from my summary of social psychology, we're somewhere between 30 and 50%. And this is, I think, a little bit optimistic as well, given everything that's been coming out in the last two years. The one I want to focus on very briefly is cancer biology, because that just like wrapped up in the last 2 years and made a big splash. And over there, we've got this preclinical cancer biology. So, if stuff doesn't replicate in social psychology, maybe not a lot of harm done, but if stuff doesn't replicate in cancer biology, if we can't trust what's happening over there, then we're in big trouble. People might die. This is pain and suffering. So just look at these stats. It's just unbelievable to look at this. They were hoping to do replications of 193 experiments. Out of those, they conducted 87 experiments, and out of those completed 50 experiments. But even in the 50, a lot of things were going on over there, things that just did not go as expected. So finally, they ended up with how many? 18. So out of 193 that they were hoping to do, they couldn't because they don't have the materials, they don't have the procedures, they don't know what happened over there. They reached out to the authors lost their laptops, moved different universities. So just unbelievable. From 193, they ended up doing 18. Out of the 18, how many did replicate well? So we've got full replications for 5, partial replications for 7, and stuff that just doesn't replicate for the rest of that. So that's not a good rate. That's not good for cancer biology. This is, we had the shock in 2015 about social psychology, but with cancer biology, we really have to do a lot better. So I've been collecting these headlines since 2015 about what's going on, and it turns out that it's not just social psychology. We've got this in different fields, including going all the way to chemical research, physics, and so forth. So we have to really revisit this. So in 2017, I was a postdoc in Maastricht University in the Netherlands. I had a year to sit down with myself to kind of contemplate what I should do about this. And when I saw these things coming out, I was just like, I have to do something about this. So I can't just keep doing usual. I really need to change the way that I do things. So I set up some principles for myself. So if you're a PhD student, if you're now entering a postdoc and you've got a little bit of time, like a year before you have to start with this job market race towards a position, then I encourage you to do this. This is what I came up with. It's not mine. I borrowed this from a lot of different people. So you can see I really wanted to emphasize registry reports. Back then, it wasn't available. So mostly like pre-registrations, effect size focus, all this stuff. And of course, transparency about everything that I do. I want to be as open and share as much as possible. But today we'll focus on replications and doing direct replications, not conceptual replications. So let's say that we don't have a lot of replications and that the success rate is not as high as maybe we hoped. So what? Why is this important? Why is it important to do replications? Do we really need to do replications? What's the benefit? So I'm going to walk you through some case studies. And for the case studies, they show you the value of replications in many different respects. And I think when people think about replications, they mostly think about the stuff that's on the left. So we've got verification, so to reanalyze the statistics in the original target articles to catch some mistakes and frauds, and I'll show you some examples of that. Reproducibility, so maybe some of the materials were lost, so now we can reconstruct them so that we can make them available if somebody wants to follow up on this research. So it wouldn't happen that out of 193, only 18 are completed, so that we have always all the materials, all the procedures, everything that we need. If the originals didn't do this, at least the replications can make all of that available so that if it works, then we can use that. If it doesn't work, then we can try and see what went wrong. Replicability is very important to either increase or decrease our confidence in the results so that we know how much to trust these results. And when we have an effect size, we want to know just how impactful is this intervention. So replications, doing this again and again, would get us to a more precise, accurate estimate of the effect size. But I also want to share with you replications don't get enough credit for advancing theory for things like measurement. So people are saying it's not a replication crisis, it's a crisis of theory, it's a crisis of measurement, it's a crisis of statistics or generalizability. So how much we can generalize from that. And to that, I would just want to say, replications address all of those things and they can help you to do better in all of these aspects. So doing more replications actually helps you advance some of the other problems that we have in science. So I'll start with one study. I think it's very relevant now because there's still an ongoing issue with one of the co-authors of this target article. We decided to do this replication of Heyman Ariely 2004. Finally, as you can see here, it was Collabora psychology. I just want to take a kind of like a side note here to tell you how we do these things. So what you can see here is that I actually conduct these things in my courses. You can see I'm at the end over there, the trailing author, but you can see a lot of Chinese names, Cantonese and Mandarin. These are my students in my courses. So as undergraduates, they conducted these replications. Actually, we had two teams of two students, undergraduates that don't have a lot of experience with running these things. Boli here is the teaching assistant, so she helped me do this. And finally, after they completed this during the course, then Hiro Imada came and helped us to submit this to the journal. So he verified what the students did. I think he's now an assistant professor in the UK. Back then, I think he was still a PhD student. So he came in, he looked at what they did, verified this, added, integrated, did all sorts of things, and then we submitted this to Collabora, and finally this was published. So I won't go into what that means exactly, but we conducted replications, and what happened doing these replications is that very fast the students came to me with questions, and they said, what is going on here? We don't understand how they calculated these effects. The statistics actually don't make sense. And I looked at this, and very fast it became very clear that there's an issue with some of the statistics. So I decided to write this all up. Once we completed the replications, we actually were able to successfully replicate these effects, but we noted that some of the statistics in the original paper are flawed. They're just wrong. So when we submitted this to Psychological Science, which is the same journal where this was published in 2004, actually we got immediately rejected, desk rejected. So even though we said, there are errors there, so first you need to fix these errors, and then because there are errors, we actually want to say we successfully replicated this despite the errors. And I posted this on Twitter. The reason why we were rejected is that we haven't moved the needle. So we haven't really shown anything interesting enough for that journal. So this was our fourth rejection. We've failed to publish anything regarding replications in Psychological Science. But the editor said, it's interesting that you found statistical errors. I'm going to contact lead author, Dan Ariely, in order to try and understand what happened here. Does he have any explanation to this or not? And to our great surprise, Psychological Science editor and Dan Ariely came out with an expression of concern saying you should not trust these findings. We found it very, very odd that they would publish this and not publish the replications that say that actually it is replicated successfully despite the statistical errors. But in general, I think this is great because this really shows that we correct the record of what's happening. And what is especially interesting is that a team of students got the credit for this. So the students in my courses, undergraduates, were able to see something in an article that was published in 2004. And get an official recognition from the Psychological Science editor and Dan Ariely. And this is what Dan Ariely said at the end. This is the way that science should progress. And this summarizes my view. You, students and early career researchers, are the key to the credibility revolution and the science reform. And you are the most underappreciated, underutilized stakeholder that we have. I just don't understand why students don't get credit for this. If undergraduates can do in my courses full replications and checking the original and finding all kinds of things that were not reported, then they really deserve a lot more recognition and a lot more involvement in science. But the odd thing is that actually nobody needed me or the students in order to know that there's a problem. Actually, in 2016, automatically there was a bot that went over all of the papers in Psychological Science and flagged everything that did not pass what's called StatCheck, which is a tool to check the p-values. So in 2016, PubPeer, StatCheck automatically wrote, there's a problem with this paper, you should check it. What did Psychological Science do between 2016 and 2022? Nothing. So what our replication helped drive is the attention of the psychological science editor in order to make sure that she validates what happened with something that was publicly known on paper even before that. So first, it allows you to check all sorts of problems and find them without with students working on over this and reanalyzing this. But let's say that if they don't act on this, that somehow replications help get the community to discuss these things in more detail. Now I'm going to discuss another case study. So that was an interesting finding mistakes, but occasionally replications also help us to find issues of fraud. This is very sad. It also has happened more recently in the case of Francesca Gino, allegedly fraud. We don't know who did the fraud exactly, but there's a lot of evidence suggesting all sorts of direction and a big mess on what's happening right now in social psychology, behavioral science. But this is a different case study, and this case study is a lot clearer. So what you have here is a paper, again, psychological science, again, 2011, still the era of hyped findings. What you can see here, you've got all the links here if you want to know a little bit more about that. What you can see here is that this was a very appealing paper because, and very, very simple, because what he suggested is that if you just change the description of a person's behavior from what the person was doing to what the person did, so imperfective versus perfective aspect, then you can get a shift in the perceived intentions. Or so a very slight manipulation on the way that you use the verb can cause all sorts of benefits that might help treatment and therapy and all sorts of other things. So you can see the kind of intervention that we're talking about. So we're seeing that they had to fill in. So it's a very implicit measure. So they had to fill in these kind of words here, and you can fill it in all sorts of different ways. The intervention was Keith, describing Keith. He was either prepared or was preparing. He read or was reading. He made or was making. So very slight difference in text. And then finally, the dependent variable was about trying to get people to write about that. And if it was related, so if they filled up these blanks in the way that was related to intentions like try, aim, goal, determination, then that would be reflective of a certain direction. And then if they do this in a, using a more neutral words. So finally, what it is that they found is that this intervention affected this dependent variable. What was the effect size? You can see that the effect size was a Cohen's d of 1. I don't know how familiar you are with effect sizes, but a Cohen's d of 1 is a very large effect. So if you don't know stuff about this, I'm going to pitch one of the other useful tools that the team created. So you can see here, Chinyu and Matthew worked on the effect size guide. So if you want to know how to calculate effect size and confidence intervals using R, so our team kind of come together. All of those are early career researchers. Matthew is a PhD student. Chinyu is a PhD student. Kit is a PhD student. So all of these are early career researchers just like you, who came in and said, we don't have a good guide on how to calculate effect sizes. So here is one that you can just go and check out. It's open, collaborative. If you go and you contribute, you automatically become a co-author. So a lot of ways for you to join and contribute. Why am I mentioning this here? Because if you look at the kind of like the benchmark of back in 1988, what did Cohen say about Cohen's d? And then later, what of some kind of evidence that we have about the effect sizes? So a very large effect in social psychology is a 0.65. So what does it mean when we have a very, 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 very slight manipulation about preparing, was preparing, prepared? It's like very small manipulation with something very implicit, very indirect about the DV, that we have a Cohen's d of 1. That is far above large. It's a very, very large effect, very implausible. So we started to do replications of this, and you can see 2016, what just happened. You can see that here's the coherence d of 1.2. And finally, the effect size that we had, if there was anything, it's in the other direction, but most of those overlap with the null. So they expected maybe not a coherence d of 1.2, but most of the labs that conducted this replication expected a coherence d of about 0.55 in the same direction as the original. But basically what it is that they found is overall overlap with the null, and if anything, there's an effect slightly in the other direction, but not significant, so don't need to make too much of this. So from this to this doesn't look very good. Why am I mentioning this? So it's a failed replication. We have many failed replications, so what? When they published this, the original authors, Hart, contacted them and said, but we already did a replication, so we already know that this works. So in 2013, we already did this. So we're just like, great. So please show us that this works. Can we see what happened exactly? So this is the paper. You can already see that it has retracted next to it. So that's not a good sign. But basically he said, look at my paper from 2013, published also in Psychological Science. I replicated this. So we said, great that you replicate. Can we just like have a look at the methods and the results and see what happens so that we can compare this to our replications by a lot of labs in order to try and see what the differences are. So he shared, he didn't share back in 2013, but given the replication, he was asked and finally shared. And then came the big shock and disappointment. So this is the, I think, dean or head of department in Erasmus in the Netherlands. He just said, okay, the authors were made to upload their data to the Open Science Framework. So I decided to just have a look whether I can explain the differences between what we did and what they did. And immediately when he opened the data set, you don't even need to be a data detective for this. You can see that just like a lot of these lines are duplicated. And when you look at which lines are duplicated, not all of them are duplicated, but the ones that are duplicated are the ones that force the effect in the right direction. So somebody it's like the most stupid fraud that you can imagine, just duplicated some stuff and then ran on this and then said, we're never going to share this. So I don't know exactly what happened over this, but there, like from 194 subjects, like 73 were duplicates, which is just odd. Why don't we share this? Anybody, you know, any reviewer that would open this immediately would see this kind of problem. What happened exactly with this author? So he's like the only author on this, William Hart. So did he not look at this? Did he cause this? Like what happened here? We actually don't know, but finally this was retracted. And finally, of the whole case study, what was the conclusion? Who did this? A former graduate student in William Hart's lab. When I saw this, I admit I had a lot of questions. So all this retraction, all this engagement, everything that happened because of the replication that drove this with the many labs in order to try and understand this effect. And this is the summary, you know, of this again from Retraction Watch. And so, you know, this was retracted, but the question remains by whom? Who did this? So there's a notice that cites an unnamed graduate student as the source of the manipulation. But the odd thing is that there's only one author, and that is William Hart. So I have all these questions. So, okay, you retracted the 2013 paper, but what happens? How can we explain what's happened with the 2011 paper? Given that you were the only author, but there was an uncredited, unnamed graduate, why are they responsible? Who are they? How did you know that it was them? Can we see what exactly happened? So just like a lot of questions that come up with this. Because many of your students, I would also like to ask why, if a student did all the things and collected the data and analyzed this, why are they not co-authors, at least credited and named? And what happened to the student afterwards with this fraud? And finally, if you didn't include the student, you just included yourself, what is your responsibility in all of that? But just a lot of questions remain. So this wraps up another. So we saw catch mistakes, catch fraud. How about theory? So this is where we're getting into a new realm, a new domain. And actually, this was the first replication I ran in 2017. I decided I'm going to start doing pre-registered applications. I asked students to join me in order to like see if we can run this together. And Lucas decided to come and join me. We did this very simple replication of Kahneman and Miller 1986 and Miller and McFarland 1986. I won't go too much into what this is, but I will just say that we measure exceptionality. So how exceptional are the circumstances and whether this impacts regret or compensation and all of that. So Lucas asked me, he said there's a difference between Kahneman and Miller and McFarland. Here the compensation is the DV, but here it's regret. So can I maybe take the compensation of what they did over there and just add regret afterwards? So I thought this is a great extension, very, very simple. So we don't have to change everything in the original. We run exactly the same thing as the original. And then in the next page, after we asked about compensation, we also ask about regret. So my first replications didn't know what to expect here. Actually was hoping that both of those would replicate very well because these are classics with hundreds of citations. But the final thing was that Kahneman and Miller with regret replicated very well, but the one with compensation did not replicate well. But luckily, Lucas decided to do this extension. So finally, when we look at regret, we see that there is a successful replication. So compensation, which is a little bit misaligned with the theory, does not work, but regret that is aligned with the theory works a little bit better. He also added other extensions like social norms and perceived luck, and these worked out great. So you can see replications and extensions help us to fine tune and try to understand what is it that is affected. Is it regret or is it compensation? Another thing that Lucas did with me is a meta-analysis that helped clarify this a little bit further. Before I show you that, I just want to say Lucas in the first meeting in 2017 came to me and said, you know, I want to do replications with you. It sounds really important. You don't know what you're doing, but I'll take a risk and work with you. Is anybody going to be interested in our replications? And then I told Lucas, I really don't know. It's the first time I'm running replications. Let's just try this out. How about you go to ResearchGate? And before we run this replication, just tell ResearchGate what we're going to do. So Lucas went here and said the aim of this project, before we did anything, we didn't even know what doing replications actually means. We're going to conduct a pre-registered replication and meta-analysis on this exceptionality effect. And to great surprise, so this was in February, in March, an incoming editor in cognition and emotion responds to my student, a master's student, and says, here at Cognition and Emotion, we are seeking to publish more pre-registered research. Please consider cognition and emotion as an outlet for this project. So I was just very surprised by this. And Lucas was very excited. Oh, we're going to publish this. There's interest. And I told Lucas, wait, you know, academia is very difficult. We don't get publications. First, we need to do the projects. Then we need to submit. Then you've got editors and reviewers and everything else. And I'm very skeptical that cognition and emotion is really interested in replication. So let's just like take it step by step. But we finished the project. We submitted this to cognition and emotion. And finally, this first replication that I ever ran with Lucas as first author was published in cognition and emotion. So I was just, oh my God, so we can publish replications. This is like a real possibility. We can help advance theory. We can help revisit classics and get credit for this so that the student, you know, can graduate with a publication. That's terrific. But maybe Lucas is special. He is not. So my other students also did this. So you can see here that he posted on 2 other students that wrote this in ResearchGate. So you can see here is Tijen and here is Yajin Gao. And in all of them, he invited us to submit to cognition and emotion. Back to exceptionality effect, Lucas also did a meta-analysis, a pre-registered meta-analysis. It's the first time that I did a pre-registration for a meta-analysis. And we actually looked at the differences in DV between regret and between compensation. And we can actually see that there's an alignment between the replication and the meta-analysis, that the effects for compensation are a lot more subtle. They're a lot more complex. There's more differences between them, and the effect size is a lot weaker. So this kind of like aligns with the replication. So now we know that if we want to measure compensation as the DV, we need to power for a much weaker effect. So we need larger samples. So this is just like an interesting like summary of this. Last case study, and this is a case study from 2019. So this is like 2 years later. I was attending a conference, SIPS, which I strongly recommend for all of you. I think this year it's in Africa. So a good chance, to go and see Nairobi and see that part of the world. So I went to SIPS, and then I was invited to give a workshop in Sweden. And they invited me, and then I said, how about we just like run a replication together? So 2 days separated by 1 day, we just do this like overnight. And I suggested that because this is a very, very short time, that we do this on a very simple target. How simple? What you see here is the article. So this is the entire method section of this article. This is an article that is 1 page. It's super simple, and it's an effect that it's called the better than average effect. So people think that they're better drivers than everybody else. On average, we think that we're better than average drivers compared to everybody else. So this was demonstrated in 1981. Super simple. There's even, if you look at the results, there's no statistics there even. So it's like people just, when I show them this page, is like, seriously, like, why would you even want to replicate this? Who cares about this kind of thing? But I have to show you the citation rate. It's actually a very, very highly cited paper. There's 2,600 citations for this paper. So maybe we need to revisit this. Do we really believe that we're better drivers than everybody else? Maybe, maybe not. So we started to look into this and do this 2-day workshop in Sweden. And we noticed some very strange things with measurement. So for example, if you look at this percentile, this was the original DV. This looked a bit strange to us because it was like 0 to 10, 11 to 20. So you can see here, the range is like 11 points, and here it's 10 points. And then it's just like screws up everything else that comes after that. So everything is skewed to one side. So we decided to just also play around with measurement. So we added two different DVs. We did this in a between subject design to see, does measurement matter? If we change the measurement, so we do this like 50 is the midpoint, and then we have the similar items, so 10, 10, 10, 10 on each direction. So does it matter? Or if we just give her a Likert scale, like 1 to 7, instead of giving a percentile 0 to 100 that has 101, and then it's difficult to like separate this to 10 or 11 points. How about just like 1 to 7? So we ran all of this together, and we saw actually measurement matters a little bit. Still, the effects are very, very high. You can see this is a very unique effect because it's really a very, very large effect. And this replicates very well across all the DVs. So we were able to find support for the better than average effect. So finally, is this publishable? And the answer is yes, definitely. We now have journals that specialize in this kind of thing. So Meta-Psychology published this. And this came from a 2-day workshop in Sweden. Happy to do this kind of thing in India or anywhere else in the world where people invite me to come and work with people to do workshops. So now we know that it's possible. Last year I did this in Norway and got some very interesting results. And everything is open, everything is transparent, including the peer review. You can just go and see every step of the way what happens. So this is what we aim for, complete open science. So to just like summarize this whole thing, I hopefully was able to show you with some case studies that replications and extensions are very important. They're very valuable. They help us to catch mistakes, catch fraud, advance theory, and find all sorts of misalignments between the theory and the method, and then also help us to advance measurement and test whether the measurement or compensate for all sorts of things that were not optimal in the original studies. Now you must be asking, okay, you've convinced us. Let's say that replications are important. We want to run replications, but we're just like early career researchers. We're just students. Can we really do this? Can students do high quality science? So I've already shown all these things that we've done were published. So Lucas, master's student, got this, Tijen, Yajin, all those were successfully published. But how about you? Can you do this? And my answer is definitely yes, a big, big yes. So I just want to show you our team. All of those are early career researchers you can from all over the world. In the last year, we also had a few new ones that are not listed here from your region, from India. So we've got all the way to Brazil. We've got different representations from different continents. I hope after SIPS this year that we'll have also from Africa. Many of those are just early career researchers, as early as undergraduate. So you can see all of my students, ran this with over 360 students. These are all the thesis students that work with me, undergraduate and masters. And here are all the international early career researchers that are working with me. So since 2021, we started to publish these, and you can see just like the impact of this team. As I explained before, what generally happens is that all these underlined are students in my courses. Then somebody, could be you, comes in and helps us to verify everything. So all these first authors are early career researchers that came in, verified what my students were doing, added a bunch of stuff, and helped together with me submit this to the journal and bring this all the way. 2022, almost the same. 2023, not completely updated, but we've got a similar number. So generally, just very high impact. And in the last 2 years, we've also started to do a lot of registry reports. I don't know if you're familiar with registry reports and what these are, but this is the way science should proceed. Happy to come back and talk to you about how to do registered reports if you want, but I really believe that this is the future, and peer community in registry reports is the way to go. So together with my students, together with early career researchers from around the world, we've been submitting all of the replications as registered reports, and you can see 4 of these are already published. There's like a lot of these with in-principle acceptance. So these are real publications. Once we complete the data collection, it will be published regardless of what the outcome is. And then a few that are ongoing. So this team works really well together. We've got templates, we've got resources, we know what we're doing. So even if you just want to learn how to do replications, how to work with other people from various places in the world, you can just like come in and join us. If you want to know how to get started, just look at our case studies. We can find, I have like a whole list of very simple replications that you can start with. We can start from like very simple extensions. I can recommend some for you. And we have templates for how to do pre-registrations and registry reports. Then we post all of the materials, the data and the code, as well as the preprint afterwards. And then we submit this to an open science supportive journal. In this case, we prioritize peer community in registry reports. And it's really suitable for students and early career researchers. This is the process that I do with all of my undergraduate and master's thesis students. So I just want to emphasize, all of the students that are doing a thesis with me submit their thesis to the journal as part of the thesis process. So you can do this within 6 months. In the last 2 years, I've successfully done this with almost all of my thesis students, and we're talking about quite a lot of them. If you want to see what a registry report looks like, you can have a look at the outputs. You can just like click on this and have a look. And I just want to emphasize, as wrapping up, is that it's really beneficial for you if you care about the community, if you want to, but also if you want to advance your skills, if you want to arrive at a publication. Registered reports and doing replications and extensions is the lowest risk possible with the highest credibility. So there's a lot of benefits for you to follow this. It's more systematic. There's a lot of value and impact because you're basing your work on things that matter. But most important, and this is what I tell all of my students, you maximize your learning. Because if you only focus on things that are novel, so you spend 4 years of a PhD, 2 years of an MPhil, all of your undergraduate, just like pursuing this one novel thing, and then it fails and it doesn't work, what are you left with? You're left with nothing. But if you separate this into a replication and extension, if both of them work, terrific. If one of them fails, then you know where you are. So for example, if the replication failed, then you know that you're not standing on solid foundations. Maybe you need to revisit those. It could be that extension worked, just like with Lucas, and then we need to update these classics. If the replication succeeded but the extension didn't, then maybe the foundations are solid, and now we've informed the community that these are solid, but then you need to revisit your novel stuff. So just like structuring this step by step, doing applications and extensions is the best way. If you want to know more, all of the early career researchers try to summarize what it is that they do. We invite everybody to do a column on Psychology Today or give a talk at HKU, Hong Kong University. So you can see Nadia, she did both the course and the thesis with me as an undergraduate. Cora is a master's student, so you can like press this and see Cora talk about this. These are international early career researchers, just like you came in and did stuff. So how did they do this? What did they achieve? You can read this on Psychology Today or see the talk by Max on YouTube. If you want to hear me talk about this for 3 hours, then you can. There's like a whole workshop on this. It's a little bit not updated 2021, but we have other follow-ups since then. So here's what you can do. You don't even need me for that. If you want to do your own replications and extensions and you want to reduce risk and you want to maximize as much as possible, you can follow the Brazilians. What the Brazilians did is that they took all of our replication, they translated this to Portuguese, and they ran this in Brazilian samples. And now they've completed 4 of those and submitted this to the journals. So that's just like wonderful to see. So if you need any help with that, I'm very happy to help you. You can just like translate this to whatever your local language is and run this with your own samples. And this is publishable. They've submitted this to Meta Psychology. I've already seen some of the reviews. This is going to get published. But you can also join us. If you like this international team, if you like what you saw over here, then you can take lead of completed replications with we've collected the data, we've analyzed this in my courses. If you prefer a registry report, we've got about 20 of those. If you want to help us with the effect size guide, if you're really good with stats, or if you want to help with any of the other 20 templates and guides that we have, you can join as a co-author there if you have something meaningful to contribute. So there's many ways for you to join us. Everything is summarized in this link, so you can just click on this and see what it means to work with us. So finally, everything that I talked about today, I know it was very short and fast, but it's all summarized on my website. So if you want to see what this team is capable of, what students, early career researchers, as early as undergraduates, second-year undergraduate, what they're capable of, just go to this link and see just the scope and the scale of everything that we've achieved in the last 5 years. And you can be part of that or start your own in your own country. So we've got a mailing list. You've got a YouTube channel with a lot of videos about what it is that I do. But if you want to talk a little bit more personal, one-on-one, I'm very happy to talk to you. Some students are a little bit scared of contacting, professors, faculty. Don't be. Even if I'm very busy, I will reply, and maybe we'll connect you with some of other people in the team. But yeah, do reach out. Do let me know how I can help you do better and implement open science. Thank you. Okay, I'm not entirely sure that I follow what the question is, but I think it has to do with like the norms of conducting replications, like following up on original studies, revisiting original. Right now, there is an issue with replication studies. There's a reason why we don't publish a lot of those. But things are changing. So we've got a few journals, definitely peer community in registered reports that has about 30 journals that support it, but also in different fields. So meta psychology that I just showed you, in social psychology, there are specific journals that are very more open science friendly. So if you're not sure in your own field which journals are like better for open science work, you can contact me and I'll help you figure this out. Within what's happening generally in science, there are some journals and some editors that are more open to this. My general recommendation, especially if you're in psychology, is to go for registered reports with peer community and registered reports, because they're open science dedicated. You've got editors who are trained on open science. Registered reports just take away all of the pressure from outcomes, because you have an in-principle acceptance on your pre-registration before you conduct any of the data. So whatever the outcome is, fail or succeed, it's going to get published. So if you conduct registered reports, if you go to these platforms, community platforms, if you go to the journals that implement open science, then there's higher chances of you to be able to successfully publish these open science replication work. If you're not sure exactly which journals are possible in your own field, you can just send me an email, and I'll send you a link to all of the journals that are available in all fields together, and then you can see which of those work the best for you. I will just say that it used to be the case that just running replications in different contexts. So for example, let's say that there is a replication, because we did this in Hong Kong. What is the value of Brazilians now suddenly running this again in Portuguese, or you running this in India in your own samples and language? There is a benefit to that, because, for example, with the Brazilians, they took one of the replications that we did where not everything worked. So there were 4 scenarios, 2 of them worked, 1 was mixed, and 1 was failed. And when we submitted this to the journal said, it's because you ran this with online labor markets on MTurk and Prolific and Cloud Research. This is the reason why it failed. Therefore, you must collect more data. What's interesting is that when the Brazilians ran exactly the same thing using the same design, they found very similar results to what we found in our replications and not aligned with the original finding. So it's not just MTurk or Prolific or all these online labor markets, but also in Portuguese in Brazil is more aligned with us. Even if it wasn't aligned, then we learned something new about what happens when we take these classic findings that were published using weird samples and go to places, developing countries, or places where things are not as straightforward and easy, and there may be some cultural nuances to this. So I definitely think, and there's a lot of journals that now recognize the importance of doing these replications with some adjustments for cultural contexts. I hope that was an answer to that. But if not, just let me know. Okay, I'll move on to another one. Often we have a notion that the larger the sample, the more reliable the study would be. Have there ever been instances where a study with a large sample had been wrong? It was difficult to replicate? Yeah, definitely happens. I think it generally decreases the chances of that happening, especially if everything is open and available. So if you know that this is a real sample, and if everything has been like validated, so all of the data has been shared, and you know that this is solid, and not I don't know, 70 something out of 190 of the participants are duplicates. If you're sure that this is real data, and you have a large sample, then chances are that things are a little bit more solid. But there are lots of nuances to this. So culture is obviously one of those. It could be time. So if you ran this in the 1970s, let's say, and it's like 50 years later, does it still hold? Holds to what extent? Weaker, maybe stronger? We don't really know. And we've had instances. So we've completed more than 120 of these replications. Some were stronger than before, some were weaker than before. And some of those were based on samples, the original studies were samples that were quite large, but perhaps, Princeton students in the 1980s is not exactly the same as MTurk's participants, online labor markets that we run nowadays. So a lot of problems with weird samples and this emphasis on small samples from prestigious universities back in the US. So it's important that I think regardless of how large the sample is, that we look at this. And for example, when we saw the Hart case study, when he said, no, I replicated this, everything is, so that specific case study was fraud. But I just in general, when somebody says I've replicated this in my lab again and again over many years in many different contexts, I am still a little bit skeptical, because I think that we independent external replications of this. Maybe it works for you because you're a magician. Every time this you run this, it just appears magically. But what happens if you give this to somebody else? If you give this to practitioners, if you give this to students, if you run this in real life, will this still hold? And this is the real test. This is science. Not that it works for one person in their own lab every time that they run this, but that you can really take this and run this in many labs around the world and apply different effects. So large sample is one of many factors that into account when we look at the credibility of original findings. We actually have a guide, a collaborative guide on how to assess the credibility of original findings. There are a lot of meta science work on this. So if this is something that's of interest to you, there's lots of directions and things that you can do in order to join us and look into this. But if you look on my website on resources, you'll see there's one guide on credibility, and sample size is just one of many factors. Okay, moving on to the next. I hope all this is helpful. I have no clue, but I'll keep going.
No, this is good. Thank you.
Okay. How does one determine the extent to which a replication attempt has been successful? That's a very good question. When researchers investigate the same scientific question using the same methods and similar tools, the results are not likely to be identical, even if we take cultural bias into some. Yeah. So even if you model all of the changes between the target article and the replication, there's just like so much variation. First, time is a variation, even if it's just like a week past. Yeah, things change. Right now there's like wars in different places. There's all sorts of context related stuff in Hong Kong. We're going through all sorts of changes. So it's very difficult to know exactly at what point in time do things change after 1 week, after 1 year, after 1 decade, after 100? So we don't know. And this is one of the reasons why we need to just check again and again, replicate as much as possible, not just once, run this in the 1970s, and then assumes that this hold for eternity. But one of the things that we really need to take into account is that once you ran the study, that study is done. Even if it's the same participants, which is very unlikely, participants change, they have their ups and downs, there are a lot of measurement error everywhere. That comes from all sorts of factors. Time is one, culture is one, but there's a lot of other things that should be taken into account. Just from today, I was working on a replication with one of the students. What should we do about currency? So for example, if we had a price of $5 in the 1980s, should we keep this $5 or should this be adjusted for inflation? How do you adjust for inflation? How do you justify this? Pound used to be very strong. Now it's not. How do you compare? So many questions and things to take into account. So we do the best that we can. But this is why I think if you closely document all the deviations and the things that might be different and all the factors, then running replications could be informative on how well this generalizes beyond the original findings. So whenever I see this one publication from whenever, could be 2011, could be the 1970s, and nobody has ever revisited this with a direct replication, I'm a little bit skeptical. So there's a lot of reasons to be skeptical of that. I also don't really know what happened in many of these articles. How did they run what it is that they ran? I always contact the original authors and ask them, can you share first the materials, but can you also share maybe the data and the code? Very rarely do our original authors share. Some of these I would consider to be like excuses. Some of them are like real things that happen. I don't expect anybody from 50 years ago to still have all the papers. They did things differently back then. Cards that they use in order to go to the mainframe and feed this in order to get results a week later. We do things a lot easier nowadays. I don't have a lot of expectations, but we do need to take into account that it's very important to run replications in order so that we have an update material, procedures, data code on how to do these things. Now back to the question of how do we know that something is successful? Very controversial, a lot of debates about this. You can use the very simple rule of thumb of if you have a signal in the same direction as the original studies. Even that very simple sentence can be broken apart into a lot of complications, but this is generally how this is assessed. We use a criteria by Lebel et al. 2019, which as far as I know is the main way to do this, which compares not only the signal, but also effect size and confidence intervals. So it tries to see whether the confidence intervals around the effect that you found in your replications include, overlaps with the effect size from the original from the original article. So that gives you a measure of what they call consistency. Is it consistent or inconsistent? Is it stronger? Is it weaker? Is it in the opposite direction? And so forth. It gets even more complicated if some of the original findings aim to conclude the null hypothesis. First, null hypothesis significance testing does not conclude support for the nulls. So a lot of the original findings are already a little bit problematic in how they used p-values in order to conclude null. But I'm just trying to give you a sense of just how difficult it is to quantify whether something has been successful or not. This is even before complex replications. So for example, in many of our studies, we have multiple scenarios, multiple studies, multiple IVs, multiple DVs, multiple hypotheses. So let's say that you have 4 hypotheses. 2 of the 4 hypotheses worked. 2 didn't work. What do you conclude? Is this successful or not? Very tricky. So we try to pre-register in advance to say, if 3 and 4 out of the 4 studies replicated, we consider this a successful. If it's 1 or 2, we consider this to be mixed. If it's 0, we consider this to be failed. Why these numbers? I don't know, but intuitively, this is what feels right to me. It's very important that we do this before we look at the data. So not after we look at the data, say, okay, so now we're going to conclude that. So we try to be as explicit as possible. So you can have a look at some of our recent register reports to see how we try and address this. But so complicated, so many things that go on. We're working on a manuscript to try and help with that, to take what Lebel et al. In 2019 did and try to generalize this to a lot of complexity. But yeah, tricky question. Very good that you raised this. It's not as straightforward as that, but you can try and relay the common rule of thumb of signal and consistency used by Lebel et al. 2019. Okay, let me see if there's anything else. Okay, how can academic community encourage more replications? Wow. Yeah, good question. I've been trying to promote this for a very long time. Even University of Hong Kong, in Hong Kong, so difficult to, I really needed to fight every step of the way, even for a thesis doing a replication to be considered a valid thesis in the first 2 years was a fight, because in the evaluation of a thesis, there was originality. And this doesn't make a lot of sense. So I had to fight to change the evaluation. I also had to, every time they gave a bad score to a student of mine, even if we published this, even if everything was like top-notch open science work, some of the evaluations were like super low, and I would go to the second examiner and say, what are you doing? This is like excellent work. And then they would say, first of all, we don't know how to evaluate replication. Second of all, I just followed the form. And in the form, there's like 20-30% of originality. So I have to take 20-30% off. And for me, this is just very, very bad. So after 2 years, finally, they were willing to change this just to accommodate my students. But the first 2 years, I've had some rough interactions, exchanges with some of the other faculty and how they evaluated replications. So every step of the way is a challenge. A lot of the open science community is trying to get journals to do more replications. There's a lot of people who are fighting in this direction, but very little, not too successful. There is a change happening, at least in social psychology. I can see the beginning of a change in disciplines like economics. But there's just like the gap is so wide that we have to push forward. I'm hoping that teams like ours, given the success of the students involved and the early career researchers, showing the impact, the number of publications, just the sheer number of people involved, I'm hoping that this is helping to drive some kind of a change to make replications a bit more mainstream, and hoping that you or others where I give talks would consider this as something. It doesn't have to be just a replication, or I shouldn't say just a replication. You don't have to focus on replication. You can do a replication and extension, and then you can put this under the title of novel studies. So you can actually do a little bit both. It's like tricking the system by doing the replication and extension. So I think this is the first step into encouraging doing more replications. One last thing I will say about this, at Hong Kong University, I failed just generally to get external research grants to support replications and my research. But the teaching folks really love that students or undergraduates are publishing. So all of our funding actually comes from the teaching folks. They're saying, "Oh, wow, undergraduates are like publishing with you. It's terrific. Here's some money for you to conduct courses." And I say, I don't need any money to conduct the courses. I'm just going to put everything into data collection. So I'm taking the teaching and putting this into the research. And in the last year, the teaching development grant at Hong Kong University, I was able to convince them to do what is called the Hong Kong University Registered Report Challenge. So basically, I told them, and this is risk-free, this is like a win-win for everybody. I told them, if a student comes to you with a stage 1 in principle acceptance register report, which is a guaranteed publication before data collection, if a student gives you that, will you be able to fund this? And they say, yeah, of course, a guaranteed publication, terrific, let's do this. So we were able to fund 30 students with a scheme up to 300,000 Hong Kong dollars, which is like quite a sum. So you're able to take something like publishing with students or registering guaranteed publication with a university like Hong Kong University that really cares about publications, not just with students. It's a guaranteed publication, and now I'm funding only what is going to be definitely published. Of course, win-win for everybody. So there are ways of using the open science practices in order to convince funders and the university in order to support your research.
So I just wanted to thank you
Yeah.
for spending time with us, and also, opening up a lot of doorways for young researchers to start their career in such a risk-free manner. So thank you so much for spending time with us today. And thanks to all the participants who joined us.
Thank you very much.